For this demonstration, we're going to take a look at the tool called Anova. We'll use the file patient data, and we want to see if the average patient satisfaction scores are the same for all offices. Therefore, our alternative hypothesis is set up as at least one of these offices will have a different average satisfaction score than the others. The null hypothesis will be set that the Main Street office will have an average overall satisfaction score that is equal to the Mall Park office that will be equal to the South Avenue office. Let's open our file. Let's get started. So according to the hypotheses we've set up, we want to focus on column I, which is overall satisfaction, and we want to break out our analysis by column D, which is office. To do an Anova analysis in Sigma Excel is very simple. We're going to go to Statistical Tools, One-Way Anova and Means Matrix, Entire Table Next. This is a stacked column format for this file. The variable we want to study, the Y variable, is overall satisfaction, and we choose office as our X variable. When you punch OK, you automatically get this analysis. The first thing you want to look for, as in all other statistical tests, is the overall p-value. And you can see right here that the p-value is 0. P is low, the null must go. The null was that all offices have the same average satisfaction scores. This is telling you there would be a 0% chance of being wrong if you rejected that null hypothesis. Therefore, at least one of these guys is different. Let's see which one. There's two ways of doing this. If you look at row 26, you have a table there that is called Pairwise Probabilities. Remember, the P in p-value stands for probability. These are pairwise p-values. In other words, if you were to pull these off and compare them two at a time using a two-sample t-test, these would be your p-value results. And it's telling you here that the Main Street office and the Mall Park office are not statistically significantly different. But look at the p-values for the South Avenue office compared to Main Street and Mall Park. They're both low. The software turns them both red, telling you that South Avenue is different than both of these. If we scroll down in our window, you will now see this analysis with confidence intervals. You learned about confidence intervals earlier. The bars here are telling you that we are 95% certain that if you went out and surveyed all patients from each of those offices, that their average satisfaction score would fall somewhere in that range. One way to interpret this is to look at the amount of overlap you have between these confidence intervals. In other words, think of them as a stack of pancakes. If you could take your fork and jab it through these pancakes, they're probably not going to be different. Notice that South Avenue has no overlap whatsoever with Main Street. Therefore, graphically we're saying it's significantly different. Statistically we're saying it's significantly different. Also, South Avenue has very little, if any, overlap with Mall Park. Therefore, we're saying that those are different as well. So to wrap this up, our final conclusion is to reject the null hypothesis because of the low overall p-value. And we're going to declare that at least one of these offices is different. Both the p-values and the graph are indicating that the South Avenue office has statistically significantly higher average patient satisfaction scores than the other two offices. Let's move on in your materials and have you try one of these on your own. Good luck.